All right, let's jump right into it. Welcome to the Explainer for Module 7, Designing and Building AI-Driven Solutions, developed alongside Dr. Ed Pearson III and the CORE Lab. If you've been with us through the previous modules, you know we've spent a ton of time really digging into the numbers and defending the facts. But today is where things get really fun. We're taking that rock-solid data evidence you defended back in Module 6 and transforming it into a fully functional, defensible AI prototype. It's time to take all that theory, roll up our sleeves, and actually build a solution that works in the real world.
So I've got to ask you a question right off the bat, and this should really set the stakes for your entire capstone project. Does your prototype genuinely solve the problem your data revealed? Or is it just a clever showcase of AI that, well, happens to be totally disconnected from the evidence? It's a blunt question for sure, but an absolutely necessary one. A prototype only earns a spot in your final capstone proposal if the design decisions are deeply traceable, the impact is actually justified, and the downstream effects have been thoroughly weighed. We aren't just making shiny tech for the sake of it here. We are designing rigorous, evidence-based solutions.
Here is our roadmap for today. We're covering 4 main pillars: prototyping and fidelity, the traceability matrix, justifying IGS impact, and finally, predicting downstream effects.
Okay, let's dive into Section 1, Prototyping and Fidelity.
Now, when we say prototype in this context, we are not talking about a polished, perfectly coded, final product that's ready for the App Store. Not at all. Instead, I want you to anchor it in this specific phrase, PACE, made repeatable. Remember PACE from our prompt engineering fundamentals? Problem, action, context, and expectations? A prototype is simply that structured prompt loop, run reliably and firmly grounded in your real Module 6 data. Think of it like this. The problem becomes your prototype's fixed purpose. The action is baked right into the system instructions. The context? That's the actual data set you spent all that time cleaning. And the expectations enforce a strictly structured output, rather than just letting the AI ramble in freeform text.
Let's look at how this builds across 4 distinct fidelity options because you definitely have choices here. You could start with a scripted walkthrough. This is the lowest build effort, essentially just a documented, fixed sequence of example prompts and real outputs. Moving up a notch, we have the guided prompt tool, where you build a reusable template that users can just fill in themselves. Then there's the interactive chat interface. This wires a simple front end to an LLM, using your data as the context. And finally, the heavy hitter, the most technically demanding option, the data-grounded assistant. This is an interface that actively retrieves information directly from your cleaned dataset before it even generates a response.
But listen, if you take one thing away from this section, let it be this. A working scripted walkthrough beats a broken chat interface. Every single time. I really want you to take that to heart. Your group needs to choose the fidelity level that you can actually build and, crucially, effectively defend in the time you have. Please don't overextend your team into building a glitchy, broken chat interface if a beautifully documented, rigorously data-grounded scripted walkthrough tells your story perfectly. Just pick what you can defend.
Moving right along to Section 2, the traceability matrix.
Let's bring this down to earth and see how it works in practice with our Rural Broadband Access Tool case study. We use a matrix with 4 mandatory columns: root cause finding, design decision, data source, and expected outcome. So our root cause finding tells us that connection rates drop sharply beyond 6 miles from a hub. Okay, because of that specific finding, our design decision is that the prototype ranks providers by distance first, cost second. Now, what's the exact data source validating this? It's the distance field showing a negative 0.61 correlation. And the expected outcome? Residents choose a closer, cheaper provider. It is literally a chain of logic. It perfectly connects the problem, the method, and the outcome into one unbreakable, testable chain.
Look, I'll be blunt. If you have a feature in your prototype that cannot fill all 4 of these columns, then it isn't evidence-based yet. It is just a guess wearing a data citation. You really have to watch out for feature creep here. Adding bells and whistles just because they're technically impressive. Or orphaned evidence, where you have a fantastic data point but no actual prototype feature to address it. A coherent chain of logic has to read the exact same forward and backward. This specific finding led to this specific feature, and this feature addresses that specific finding. Period.
All right, part 3, justifying IGS impact. To load test your prototype and prove it actually improves the capstone's MC Inclusive Growth Score, or IGS, you need to rely on 4 essential metrics. First up is the baseline. This is where your target population sits today, the status quo, drawn straight from your evidence. Next, identify the specific target subscore your prototype addresses, something like access, time, or cost burden. Then comes your projected shift,
which is the directional, quantified change you actually expect to see. And finally, the status quo comparison. Remember, an impact justification is always a comparison against the status quo. What happens to the subscore if literally nothing changes? We are never comparing against some idealized perfect world.
Now, to properly justify that projected shift, your argument has to rigidly contain three core elements. First, a mechanism. You need to explain exactly how using the prototype changes a resident's decision or situation. Second, a magnitude. State how large a shift you expect and over what specific population or time frame. And third, evidence. You must cite the exact Module 6 statistic that supports both the mechanism and the magnitude. You can't just throw out a correlation and cross your fingers. You need hard data backing up both how the tool works and how big of an impact it's actually going to make.
Scoping your claims honestly is so absolutely crucial. Imagine pitching your project and saying, this tool will close the broadband gap. Wow, hold on a second. That is completely overclaimed. A single tool rarely solves a massive systemic issue on its own. Now contrast that with a properly scoped version. This tool is expected to help lowest connectivity tracks identify lower cost options pending real-world testing. See the difference? A confirmed correlation definitely supports your mechanism, but it does not automatically guarantee a massive magnitude. So keep your claims modest, make sure they are testable, and strictly tie them to what your data can actually prove.
And that brings us to our fourth and final section, predicting downstream effects.
Before you even think about packing up and leaving the demo stage, you absolutely must ask yourself these questions about what happens at scale. Who else is affected beyond the intended user? Are providers or future applicants going to experience second-order effects? What happens with heavy use? Does the tool behave the exact same way for 10 users as it does for 10,000? Or does a hidden bottleneck suddenly emerge? And what happens with the wrong input, or for a user who has no internet access at all? Listen, framing long-term prediction like this isn't about being pessimistic or shooting down your own ideas. It is simply evidence-based reasoning applied one step further down the timeline.
Returning to our broadband case study one last time, we have to honestly weigh the likely benefits against the plausible trade-offs. For sure, the clear benefit is that it reduces a documented information gap for residents actively seeking service. That's great. But the trade-offs? Well, concentrating demand on the top 2 or 3 providers might strain their capacity. And crucially, an online tool completely leaves behind the folks who don't have internet access to use it in the first place. You know, naming a trade-off like this doesn't disqualify your prototype. Actually, omitting it from the proposal is what gets you in trouble. Highlighting your trade-offs actively strengthens your capstone proposal because it proves to the panel that you understand the real-world complexities and can actually propose mitigations.
And that brings us to the end. I want to leave you with this provocative final thought to chew on. Your prototype works in a demo, but who does it leave behind at scale? Think about it. A working evidence-linked prototype is really a capstone proposal half-written. I challenge you to take everything you've built here directly into Module 8, where we are going to tackle ethics, equity, and responsible AI deployment head-on. Thanks for joining me for this explainer. Stay focused, and honestly, I cannot wait to see the defensible prototypes you all build.